All right, hi again, you guys. So today we are looking at lesson 5.1, and so we're going to start getting into some of the different operations we can do with radicals. So if you remember last time we did a little bit of a review of radicals, looking at mixed and entire radicals, and basically how we can kind of switch between those two. So to start out with today, we kind of want to do a little bit of an investigation to remember some math that is basically going to help us with what we'll be doing with radicals next. So quick little bit of review. What is a radical? So remember that a radical is, and if you want, actually, it might be a good idea to pause the video, because what would probably work best for you to really learn this material is try and work through this investigation on your own, first of all, and see if you can answer these questions. Some of it is going to be review, so hopefully that means you can answer it, and other stuff is going to kind of bring back a little bit of stuff from Math 10C, but see if you can remember it and then come back to where we're at now. So you can just pause the video and go ahead and go through it and then check your answers against what I do here. So first of all, what is a radical? I'll give an example below. So remember, a radical is basically anything where we have a root operation being done to a number. So it could be like square root of 7, or it could be a cube root of 52. So I'm just making up totally random numbers. Remember, we can also have mixed. So you could have like 2 root 6, for example. So any one of those would be considered to be radicals. So we can have different indexes, remember that number there, and we can have different radicands, so the numbers that are under the radical sign, and we can have entire radicals like these two, or we can have mixed. All of those are examples of radicals. So can you provide an example of a mixed radical and an entire radical? Well, we just kind of did that. Here's our mixed radical, and then both of these ones are entire radicals. Okay. What are like terms? So this is where you would have to think back a little bit to Math 10C. I can't think about if we've really talked too much or used the word like terms in Math 20-1 so far. I guess we kind of would have, because basically you would have been looking at that a little bit with quadratics where you're simplifying things. So like terms are basically what you would have looked at so far would be, for example, variables that are identical with each other. So for example, if we have 3x squared and x squared, so when we're thinking about like terms in terms of like algebraic terms, it doesn't really matter what the coefficient is, as long as the variable is identical with each other, then you can do operations like adding and subtracting with each other. So let me think, what else would I say? So then we would think, like, would x be a like term with these two? Well, no, it would not, because there's no exponent for this one. So x would be a like term with, let's say, 16x, or a half x. So the coefficient can change, but it's not going to be a like term with the squared value. So that means you would not be able to add x to 3x squared, for example. Okay, so when we're looking for like radicals, based on what we just said is involved with a like term, what do you think a like radical might be like? Well, one of the first things is the index is important. So do you think that we would be able to combine or work together with a cube root and a square root? Well, no, because they're not considered like. So for example, if we had the cube root of 6, and we had 3 cube root 6. Would those be like terms? So the answer is yes, because of 2 reasons. The radicands are the same, and the index numbers are the same. Okay, so in order for radicals to be considered like, both of those components need to be the same. So for example, what would not be like terms is if we had these 2 terms, we couldn't have like 2 root 6, for example, because it doesn't have the same index. Or we couldn't have 3 cube root 4 because the radicand is not the same. So these would not be like terms. Okay, so given the following radicals, they want us to say which ones are like radicals. Well, all of them, if we look at them, they're all square roots, so that's good. So now all we need to look at is which ones have the exact same radicand. So we have a 5 root 7 here, and then we have a root 5, root 3, and one more root 7. So this and this are going to be like terms. Okay, same index, same radicand. Group like radicals in this second group. So now we're getting a little bit more complex because we have variables. So this one here we can see is 5x squared, and it's a cube root. This one is also a cube root with 5x squared as the radicand. So this one and this one would be like terms. The other one we can see in there is we have 5a and 5a, which looks good, but if you pay attention, we have the 4th root and the 5th root. So those are not going to be like terms. So we can't group those together. So what conclusion can we make from this? Well, basically we can say that for radicals to be considered like radicals, they have to have, so like radicals have same index and radicand. Okay, so if we were to look at simplifying a bunch of radicals, what do you think would be the rule? Why do you think that I might have brought up that information about adding 3x squared and x squared? Well, the reason is the rules are the same for radicals. You can combine like radicals, but you cannot combine non-like radicals. I don't know what the best way is to say that. So what we would want to do here is look at which ones can we combine. We have cube root 7 here and cube root 7 there. So those two are going to be like terms. And then the other ones we have are both square root 7. So both of those can be combined with each other. So then what we want to do is think about how do we combine these. And that can be a little bit tricky, but basically all you have to do is, if we think about what we were talking about up here, if you had 3x squared plus x squared, what would you do? Well, you would do, this is our coefficient here is 3, and the invisible coefficient there is 1. So we have 4x squared, right? We don't change the variable component there. It's just the coefficients that change. And so we do the same thing when we're combining like radicals. So if we want to combine 3 cube root 7 with 4 cube root 7, first of all, always make sure you keep the addition or subtraction sign together with the number that comes after it, basically. So we're going to have 3 plus 4 for our indexes, or sorry, for our coefficients. So 3 plus 4. And then those are going to be both for cube root 7. Okay, so that's going to be kind of one thing we can combine. Then, again, here it can be a little bit tricky because this one is out front there and it's coming after this one, and lots of students get confused by that. But we're basically going to have -6 here, -6 plus, and then here there's no coefficient, so basically it's the same as like +1. And then both of those are going to be root 7. Okay, so now if I combine it, 3 plus 4 is 7, and then my cube root 7 stays the same. -6 plus 1 is -5, and then root 7. So this is going to be our simplified version of adding these all together. Mostly the trickiest part that I find for students is remembering that you don't need to be messing around with changing your radicands for adding and subtracting. When we get into multiplying, that's going to be a little bit different, just the way it is with like terms like this. So with radicals, the multiplying and dividing is going to be a little bit different of rules. But with adding and subtracting, you only worry about the coefficients, and it has to be for like radicals. And then the other thing that most students, like the area I see most mistakes being made of, is not remembering how to keep your negatives and positives together. So I like to just totally group them and don't even think about like I don't know, like going back and forth. Like basically I would say, okay, I have +3 here and I have +4 there. So when I combine those two numbers, I get +7. And then I would look here and say, okay, I have -6 and +1. -6 plus +1 is -5. So what I see then when I write this out is that it's 7 cube root 7 minus 5. So we say it a little bit differently when it's like that, but basically as long as you've combined your numbers correctly, you're going to come up with the proper operation. So in this case, that's subtracting. So what conclusion can be made about adding and subtracting radicals? Basically, all I want you to understand from this is that just like when you add and subtract like terms in like a polynomial, for example, you only perform the operation on the coefficients. The radicals remain unchanged. Okay, and you can't combine between unlike radicals would be another thing to take away from this. Okay, so let's look at some of the key ideas for this lesson. Basically, we kind of just came up with it by doing that investigation. So radicals with the same radicand and index are considered to be what kind of radicals? Like radicals. You can combine like terms by adding or subtracting their coefficients. So 4 root 3 and 2 root 3, are they or are they not like? Well, they both are square roots, so that's good, and they both have a radicand of 3, so they are like radicals, and so that means you can add or subtract them. 4 root 2 and 2 root 3, are those like or not like? Well, they're both square roots, but this one has a radicand of 2 and this one has a radicand of 3, so they are not like radicals, so you can't add or subtract them with each other. What about 4 root 3 and 2 cube root 3? This case, they have the same radicand but different indexes, so again, they are not like radicals, and so you can't add or subtract with them. Okay, so I mean, I kind of gave it away by putting the way that it's worded there, so you probably caught on to that, but it's a good idea for you to really be familiar with those rules. So some things to remember before we move into trying some examples are, before you add or subtract, you want to convert entire radicals into mixed radicals. Because sometimes when you simplify them, you'll find that radicals you thought were not like radicals actually are when they're in simplest form. So you always want to have things in their simplest form. Keep all the numbers in radical form. Do not use your calculator to evaluate. So basically what that means is on a test, you can't just put in like 5 root 2 plus 3 root 2 minus 2 root 2 and give me the decimal number that your calculator comes up with. You will not get marks for that, because the whole point of this unit is that you have to be able to work with radicals directly, okay? So not using your calculator for that. Okay, so if we want to simplify these guys, the first thing we want to look and see is if any of these radicals or radicands can be simplified. And they're all 2, so no, they cannot. But the next thing we notice is they all have the same index and they all have the same radicand, so that means that they can all be combined with each other. So basically what we're going to have is +5 plus 3, so always remembering to keep those values together, minus 2. So 5 plus 3 minus 2. 5 plus 3 is 8, minus 2 gives us 6, and then we just keep the radicand after that. So 6 root 2 would be our final answer for that one. Okay, what about this one? We have 7 underneath all of those, which can't be simplified whether it's a square root or a cube root. So we have a cube root 7 here and a cube root 7 there. And then we have square root 7 and square root 7. So it's a good idea for you to get used to kind of keeping your values together that are like terms. So we're going to be able to combine plus 3 plus 4, right? So 3 plus 4 gives us 7 cube root 7. And then here, again, keep your values. So -6 plus, and then there's no coefficient there, so it's going to be +1, gives us -6 plus 1. Remember, that means you're moving closer to 0, so we have -5. And then the radical that comes after that is just root 7. So now if I want to make these into an expression that has adding and subtracting, I can say 7 cube root 7, and then minus 5 root 7. Okay, you might have a different way of doing that. I know in the filled in notes that I posted, I didn't separate them out quite like that. So kind of whatever you're comfortable with. I just find that when you do it this way, it helps to keep those negatives and positives in the right place. Okay, next one, simplify the following. So we have 12, 18, 27, and 8. None of them look like they're the same. So then what we need to do is simplify, like factor out basically our radicals first and see how we can make them into mixed radicals in their simplest form. So 12 is basically 4 times 3. And remember, 4 is 2 squared times by 3. So what we're looking for, because these are all square roots, is any squares that we can take out of there. What about 18? Well, 18 is 9 times 2, and 9 is 3 squared times by 2. So that's a square that we can take out. 27 is 9 times 3, and 9 is 3 squared times by 3. Okay, so that's good. And then 8 is 4 times 2, so that's 2 squared times by 2. Sorry, that kind of went off way far, but I don't have a ton of room to work on the bottom of this page, so I'm just going to keep it like that. So now I just want to simplify all of these. So the first one, I have a 2 that can move to the outside, so it's going to be 2 root, and then my remaining factor is 3. For this one, I have 3 squared that I can move outside, so I'm going to keep this the same, plus 3 moves to the outside, and root 2 stays inside. And then minus, so keeping all my signs the same, 3 squared, I'm going to square root that, so that gives me 3 on the outside, and then I'm left with the 3 on the inside. And then I have plus and 2 squared, so 2 can move outside, and then on the inside we keep the root 2. Okay, so now I have everything in its simplest form, so I can go ahead and start looking at finding like terms. So I have 2 root 3 here, and negative 3 root 3, those are like. And then I have positive 3 root 2 and positive 2 root 2, those are like terms. So I'm going to have 2 minus 3, which gives me negative 1. And remember, you don't ever put in a 1, so I'm just going to do negative root 3. Okay. The other terms that I have here are positive 3 plus 2, which gives me 5 root 2. So now if I want to write this as my full equation, I'm going to have, you can do it either way. Some people don't like to keep this negative out front, so you could either put your positive value first, 5 root 2 minus root 3. That would be okay. Or you can do negative root 3 plus 5 root 2. Both of these are acceptable. Okay. All right, one more like this. So we have 4 root 3. Can't simplify 3 anymore. There's no factors in there. 20 we know is 4 times 5, and 4 is 2 squared times by 5. 12 we know is 3 times 4, and 4 is 2 squared times by 3. 45 is 9 times 5. 9 is 3 squared times by 5. So 9 times 5 gives us 45. So now I can start breaking these down. I'm going to have 4 root 3 plus the 2 squared is going to move outside, and I already had a value here. So basically I'm going to move, remember it's just the 2 because we square root it because it comes out from under the square root. So 2 times 3 is going to give me a coefficient of 6. And then what's left underneath here is root 5. And then down here it's going to be minus, so keeping everything the same, 2 squared, so I'm moving the 2 outside. There's no coefficient to multiply it by, so that's fine. And then root 3 stays underneath there. And then for this guy, I have a coefficient of 6. First I should put in the plus. I have a coefficient of 6. The 3 is going to move outside, so 6 times by 3 gives me 18. And then I'm going to be left with the 5 underneath the radical sign. So now I want to look at like terms. I have root 3 and root 3 here, and then I have root 5 and root 5. So let's look at how we can combine those. So 4 minus 2 gives me 2 root 3. And then positive 6 plus 18 gives me plus 24. And the radicals with those ones are root 5. So there it is. So you can see how if you get more comfortable, you don't always need to break it down into these like 2 steps and then make it into an equation. You could just start doing the addition in your head, or I mean, if you really need to, you can use your calculator. Although of course I encourage you to try and work with your number skills by doing things in your head. And then if you're just starting to get used to doing that, you can always do it in your head and then check it against your calculator, because what happens a lot of times with math is a lot of people kind of have a little bit of a fear about it, and then they never really start to like build their confidence in their skills by doing things like that. And you'll be surprised. I really think you'll be surprised if you start doing some of this addition in your head, and those numbers, especially the more you do math, the more those numbers kind of come together more and more naturally. And then when you check against your calculator, you'll start finding more and more that you're able to, get the number right pretty quickly. So I really highly recommend that you try doing that so that you improve your math skills, because it will make the rest of math easier when you start to be able to recognize, those patterns of how things combine with each other. Okay, so let's try an example where it's kind of more like a word problem. Write and simplify an expression for the perimeter of a rectangle. So this is some good math vocabulary to remember. What does perimeter mean? Perimeter always means the distance around the edge of something. So whenever you're looking for perimeter, you're basically adding together all the sides. Now, because this is a rectangle, we know that this other side is 2 root 3, and this other side is going to be the same as that one, so it's going to be 4 root 2 minus root 3. Okay, so basically what we're doing is we're adding all of the sides together. So we know that it's going to be 2 root 3, and I might, just to keep things easier, I'm going to keep the sides together. So it's going to be these two sides added together, so 2 root 3 plus 2 root 3. And then I'm going to add plus 4 root 2 minus root 3. And then plus 4 root 2 minus root 3. Okay, so there's my whole expression. Now I want to start looking for like terms. So I have a root 3 here and a root 3 there, root 3, root 3. Lots of root 3's. And then I only have these 2 root 2 terms. So let's start out by combining the root 3's. We're going to have positive 2 plus 2. This is a root 2, so we skip that one. The negative stays together. There's no coefficient, so it's basically minus 1. And then, where's our next blue one here? So another minus 1. So 2 plus 2 is 4, minus 1 is 3, minus 1 is 2. And then the radical that went together with all of those was 2 root 3. Okay, now the other two, we can probably just add one because they're pretty easy. There's only 2 of them. So positive 4 plus 4 gives us plus 8, and then the radical stays the same, plus 8 root 2. Okay, so it's just as easy as that. Just find the like ones, make sure you keep the positives and negatives together, and then you can start combining them. Okay, last question here. Simplify each expression. Identify any restrictions on the values for the variables. So we haven't looked at restrictions since the last lesson. So remember, the restriction just refers to the fact that if you have an even numbered radical, you cannot square root a negative value underneath it. So essentially what that means is whatever value you have here as a variable, it can't be less than 0. Okay, so let's see, simplify each expression and identify any restrictions. Okay, so first of all, let's look at simplifying. So we have square root, that's fine. And then we need to look at the radicand, which is the same, a cubed, so we can just combine these. So we're going to have plus 2 plus 6 is going to be plus 8, and then a cubed. Now what we want to do is simplify this really quickly. So we had them as like terms so we could combine them first before we simplified them because they were already the same. But now we still want to simplify it, right? Because it says simplify. So can we break this down any further? Well, we know that this is a square root and we do have a squared in there. So it's going to be a squared times by a, right? Will give us a cubed. And then because we have this squared value, that means we can move an a outside. So we're going to have 8a square root a is our final term. So now we would need to say, what are any restrictions that are on this value? Well, this number can't square root to anything. Sorry, let me think about that. Can't square root to anything less than 0. So basically all we would have to say here is a has to be greater than or equal to 0 is our restriction. Okay, because if this number is square rooted, as long as it's above 0, like if it's 0, it'll be square root of 0, which is 0. If it's anything above it, it'll still be positive, so that's good. Okay, let's have a look at this guy. We don't have, well, these two are like terms, but first of all, maybe with this one, we should look at simplifying if possible. So 2, we can't square root 2. We could square root this guy, so let's break this down. So 2x is going to have to stay the same. 8 is 2 squared, which is 4 times by 2. So that means we're going to be able to bump that 2 outside, and the x is going to have to stay. Same thing for this one. It's just an x, so it's going to have to stay. So now we can say 3 root 2x plus, we're going to bump this 2 outside and multiply it by the coefficient of 3, so that's going to be 6. And then on the inside, we're still going to have a 2 and the x. And then, what else do we have? Minus root x. Okay, so these two are our like terms that we can combine, and then the other one is going to have to stay on its own. So 3 plus 6 gives us 9 root 2x minus root x. So that is our simplified statement, and now we need to think about what would be our restrictions on this. So similarly to the previous one, we can basically just think we know that we want both of these values to never be less than 0. So if we said x was greater than or equal to 0, would this value always be above 0? Well, 2 times 0 would be 0, and 2 times anything above 0 will be above 0, right? So as long as x isn't less than 0, this one will be fine. And then because this is just a variable, the exact same thing, right? If it's 0 or above, then we're good. So we can state basically the exact same restriction for this one, which is that x has to be greater than or equal to 0 as our restriction. Okay, so those are our answers for those. So you guys have an assignment from the textbook, page 278 to 281, bunch of different questions there. Try them out, check your solutions to make sure you're getting these correct. And next time we're going to look at multiplying radicals. So the next section in your textbook is actually both multiplying and dividing, but I've decided to break it into 2 different lessons. So we're going to do multiplying radicals as one lesson and dividing as another. So I will see you then.